In this video, we're going to take a look at the definition for a conditional discrete probability function of y1 given y2. So again, we're going to look at jointly discrete random variables, and then we'll look at an example where we play with this a little bit. All right, so if y1 and y2 are jointly discrete random variables, so they are discrete, with a joint probability function, p of y1, y2, and marginal probability functions, p1 of y1 and p2 of y2 respectively, then the conditional discrete probability function of y1 given y2 is going to be this, right? Probability of y1 given y2. And so that is the probability that y1 equals little y1 given that y2 equals little y2. And so that would be equal to the probability that y1 equals y1 and y2 equals y2 over the probability y2 equals y2. But what is that? So that top part is really our joint probability function, right? P of y1, y2. And the bottom part is simply that marginal probability function. So that's what we have. So let's look at this. So when we're going to find this conditional discrete probability function, let's do that in an example. All right. So from a group of 3 Republicans, 2 Democrats, and 1 independent, a committee of 2 people is going to be randomly selected. We want to find the conditional distribution of y1 given that y2 is equal to 1. Right? And so that's what our goal is, find the conditional distribution of y1. Right, so the distribution of the number of Republicans on the committee, given that there is 1 Democrat on the committee. Right? Given one of the 2 people on the committee is a Democrat, find the conditional distribution of the number of Republicans on the committee. And so we have previously looked at this a little bit, but let's look here. The probability that y1 equals 0 given y2 is equal to 1. So that would be the density function where we have 0 Republicans, not density function, the probability function where we have 0 Republicans and 1 Democrat over the marginal probability function of having one Democrat. Right? And so I'm going to turn back the page to see where we looked at this example before. Right, so here's where we looked at this example before. So we are looking for the probability of 0 Republicans and 1 Democrat, and so that we find that in this table. We have the top row is, so this is 0 Republicans, this is 1 Democrat, and so we're looking for this value right here, 2/15. So that's going to be our value on top here. We want to divide that by the marginal probability that we have a single Democrat. And so there, that marginal probability of having a single Democrat, that is this 8 out of 15. Probability of having exactly 1 Democrat is 8 out of 15. And so that's our bottom value. So we get 2/8, or 1/4. The probability that y1 is equal to 1 given y2 equals 1. P of 0, nope, no longer 0, now that's a 1. 1 comma 1 over P2 of 1. Right, so when we look back, we have 6/15 right there in the middle of that. So that 6/15 is y1 being 1 and y2 also being 1. That value on the bottom is still the 8/15. So we get 6 over 8 or 3/4. You might notice at this point in time those two probabilities add up to 1 because the probability that we have two people, two Republicans on the committee, on this two-person committee, given that we already have one Democrat on the committee, that is going to be equal to 0. And so that gives us our conditional distribution of y1, given that y2 is equal to 1. Sorry for that pause. Yeah. All right, that's what we have for that first part. The second, oh yeah, that's it for that example. So on the next video, we're going to look at conditional density functions.